love doing these groups because Anna and Kyle take such good care of us with warm blankets, and it's the most important thing to be somewhat comfortable physically so that we can then get into the higher sensory and thinking centers. But yeah, so I'm Zarrin, and I'm a human being, and I have a brain and I have a physical body, and as do all of us here. And there's something interesting where what we feel on Earth doesn't correspond to what we think about astronomy. Does it feel like Earth is moving at 90 times the speed of sound, racing around the sun?
Nope.
It feels like Earth is not moving. And yet what we think, right? We, being modern people who have embraced Copernicanism, the idea that the Earth runs around the sun at 90 times the speed of sound, but we can't feel it. How strange. How interesting. And over time, after telescopes came into the modern scientific era, more and more movements have been ascribed to Earth. Now we think that the sun and its planets rushes around the center of our galaxy, and our galaxy itself is moving, and we can't feel any of these things. So there's this interesting distinction between what we feel and what we see. There are so many other ways that looking at the night sky changes our perspective, I think. The beginning of astronomy was largely inspired by a desire to have better predictions for astrology, strangely enough. Well, maybe some people are still interested in astrology. Anybody here like astrology? Some people still do, but it's not so popular now. Maybe we don't look at newspapers anymore, so you don't even get your horoscope probably on the digital news anymore. And of course, different newspapers might say different things. But at least now we can predict where the planets will be thanks to astronomy. And astrology used to try to predict where the planets would be based on an idea that the Earth was at the center. Tonight we can replicate one of the early observations that was so important for astronomy, made by Galileo. And has anyone heard of Galileo? Yeah, everybody's heard of Galileo.
Yep.
He's one of like those famous people from science. And maybe Copernicus. Anybody heard of Copernicus? Or Newton? Or Einstein? We'll take a look in the Dobsonian, named for John Dobson. Anybody heard of John Dobson?
Don't know that one.
He passed a few years ago, and he started the Sidewalk Astronomers in San Francisco and went to many national parks, and he invented this style of mount for a telescope, which in the general sense is a Newtonian, named for Isaac Newton. And this is a very simple style of mount which gets pushed around mechanically, and it was cheap to build. And he thinks he showed the moon to perhaps 1 million people in a telescope in his lifetime. He ground mirrors, he built his own telescopes, and maybe 60 years ago it was more common to get a telescope kit than build your own. Anybody ever try it?
No.
I never have either. I've bought mine which were made in China, and it's amazing the quality and lack of expense of goods that you can get from China. They're pretty nice. And the other telescope has a camera and does astrophotography, and is controlled by my smartphone. It's good for looking at faint objects like nebulae and galaxies besides our own. So we'll take a look at Jupiter in the Dobsonian, and we will see moons around Jupiter. And Galileo observed these moons going around Jupiter, although his telescope was not as good as my Chinese-made instrument. And that showed him that the Earth was not the center of everything. There were things going around other things out there. Does anyone know where Jupiter is right now?
Oh, that's right.
This one right here.
That's a good laser pointer.
Very cool.
And I'm glad I have a laser pointer which Galileo didn't have, or the ancients when they made up the constellations. And it sure is useful. How else would the ancients have described that here's a bighorn sheep? And quite obviously, there's a bighorn sheep. Yeah, everybody can see that that's a bighorn sheep. It couldn't be anything else. Besides a bighorn sheep, those 4 stars. And how would you know which ones I was talking about without the laser pointer? It would be much more difficult. So that's the constellation of Aries.
And that one's Subaru.
Yes, here is the Pleiades, or the Subaru in Japan, or the Seven Sisters. Yeah, no, it's called the Subaru, and on the Subaru logo there are 5 stars. Many cultures had the same groupings of stars, the same groupings of bright stars in the same part of the sky for star myths. And almost all cultures had star myths because they didn't have Netflix, and this was a good way to tell stories and remember them over time. But they would make different stories based on their cultural context. The same stars seem to go together, though, to all people, and through all of recorded history, they pretty much haven't changed. And the patterns of the stars over very long periods of time will change, but in our human context, they're still basically the same as in ancient Egypt or the earliest recorded periods in Sumeria. But the planets and the moon and the sun move through the constellations, and we would describe tonight that Jupiter is in Taurus. If you were doing astrology or just in astronomical terms describing where it is, and it will move through the constellations of the zodiac in 12 years, which is the year of Jupiter. So it'll take about a year in each of the 12 zodiac constellations. We can see the brightest star of Taurus here. This is Aldebaran, and there's a faint V shape of the head of the bull. And then we make big horns here pointing to those 2 stars, and Jupiter is right in the middle. And then the body of the bull is back here, and it's kind of faint. This is kind of like the body, and there's a little leg there, and maybe there's a back leg down here and a little tail. But the head and the horns are the real highlight of Taurus. Some constellations look kind of like what they are. Some, like Aries, don't really. There are some good ones. What's a constellation everybody's heard of?
Big Dipper.
Big Dipper, we can't see right now. It's below the horizon. Cassiopeia is a good one. Here. And
What is Cassiopeia?
A queen, yes.
The queen.
In a chair.
A queen in a chair. Hard to make a queen or a chair or a crown or something out of this W shape. Yeah. Tricky. A queen in a chair sounds good. How do we orient this chair? Is the queen sitting upside down, or I'm not sure. But maybe you can picture it in your mind's eye. And there's an important star near Cassiopeia. What's the most important star in the sky?
North Star.
You bet. Anybody know which one is the North Star? Anybody want to use the laser and take a guess?
Bill,
No,
don't forget.
no takers.
Go for it, Bill. Bill.
All right. This is very cool.
Isn't that
I'm
fun?
going to go with that one.
Good guess, but no.
Looks
just
wrong
like it.
again, Bill.
We are looking toward the north here.
We are looking
So
towards
I-
the north.
we
Or
conveniently
that
set
way.
it that way. Yes, there it is.
That one.
Where?
Okay,
That's
I
the
was
North
off by a
Star.
few degrees.
Yeah, just a few degrees. And how do we know it's the North Star?
Because it's north.
Oh, yeah, you could use a compass and take a guess.
I've got a question for you. I was at a presentation like this a number of years ago, and somehow we got into the North Star. And they said, well, it's only been there for a couple million years, right? And he goes, no, it's been there for less than 10,000. Is that right?
Do you want to talk about this topic? I'd love to. It's
Well, if you've got something more important, but I was just, I figured nothing's really changed in the last million years. And he goes, no, the North Star's only been there for about 10,000 years.
It's a topic that I get into sometimes because it's a significant part of the research that I've become involved with. Why does the North Star change over 24 to 26,000 years in a cycle called the Great Year by Plato, or the Yuga cycle in the Vedic traditions of India? Well, we don't know why. We still don't know in astronomical terms what causes this change, and that's what my research interest has been. But we do know that it is an observable change, and the North Pole currently points very close to the North Star. Not exactly at it, about right here. And over 24 to 26,000 years, the North Pole of the Earth will point variously along this circle. So yes, the North Star is only temporarily very close to being in alignment with where the North Pole is pointing. Well, the long-standing explanation for why this occurs is called the lunisolar wobble theory of Isaac Newton. And the lunisolar wobble was also a popular dance shortly after the electric slide came out of favor.
What are you guys talking about?
What are we?
Show us.
Who knows? The lunisolar wobble suggests that Earth wobbles once in 24 to 26,000 years. But there are certain observations of how the moon and planets align with the stars, which indicate that the local motion of Earth, such as is described by a lunisolar wobble theory, cannot account for the precession as it is observed. So Newton's idea was a good idea at the time, but as observations have become better, it can be said very shortly that his mechanistic explanation for the cause is not correct, and it's unknown really at this point what the cause is. Does that make sense?
So the location of the North Star is not so much a problem with the star, it is the problem with Earth.
Yeah. Earth is moving, and there are many motions of Earth.
I'm sorry, go ahead.
Yes, and we don't know which movement or exactly how Earth or our solar system is moving in a way which accounts for the observable phenomenon precession. We don't know what causes this movement or exactly how our solar system is moving. The observations which show that the local motion of Earth, which includes ideas like the lunisolar wobble theory, can't account for the observable precession, means that our whole solar system must be moving in such a way as to cause the precession. So local motion of Earth can't be causing it. Something is causing a slow wobble, so to speak, of our whole solar system. And we don't know what it is yet. But a good possibility is that there's some kind of other body which has a relationship with our sun, such as some kind of a binary partner. And the reason this is probably the explanation, although the details are not known at this point, is because over the course of astronomical history, we keep discovering more and more binary star systems. We never discover less. Just more and more, to the point where now 85%, 90%, the estimates continue to increase as to the percentage of stars which are binary or triple star systems or quadruple star systems. The old idea, which was understood in Newton's time and Galileo and Copernicus' time, that the sun was a single star, may not be true. If it is true, it's definitely in the minority. Most of the stars that we see with the naked eye, perhaps all of them, are not just one point of light, although that is all we can see with our naked eye. They are in fact two. And as telescopes have gotten better, each of these points of light, which look like one star, have become understood to be 2, 3, 4. And many of those stars also have planets. The big idea of astronomy is that the stars are like suns. Each of these points of light is like a sun. And it really boggles the mind. Did everybody know that, so to speak? The stars are like suns? And just over the past 20 years has been the advent of adaptive optics and improvements in spectroscopic analysis, which have identified more and more binary stars and also exoplanets. But even with our great telescopes and the James Webb Space Telescope, anybody heard of that one? Yeah. Even the James Webb Space Telescope cannot see detail on almost any of the stars except for the sun. There are 24 which have been resolved into an amorphous blob with no real surface detail visible. And every other star is visible only as a pinpoint of light. The only data that we can obtain from it is its position from our perspective, its relative brightness, and the spectra of its light, and including other parts of the electromagnetic spectrum besides the visual, like the infrared, the radio, the X-rays if you're using a space telescope, and whatnot. But we cannot see the stars, we can only see their light, to quote Christopher Graney from the Vatican Observatory. But we can see that most of these points of light, they come in pairs, almost all of them. And if our sun has a binary companion, it would explain precession in a way that matches with the observable, which indicates that our whole solar system is slowly wobbling in 24 to 26,000 years to create what we can see that we call the precession, including the different places where the North Pole is pointing, and also including the change in the spring or the fall equinox, which results in things like in the musical Hair, where they say the dawning of the age of Aquarius. This also refers to the great year cycle and the spring equinox changing from Pisces into Aquarius. And this is a good thing, I suppose.
So you're saying that we could be part of a sun pair, we're just too close to be able to tell?
Yeah, it's a good question. If we are part of a binary star system, where's the other sun?
Yes, exactly.
Yeah, it's a very obvious question that comes up, and it is somewhat strange that we don't clearly see a binary system around us, if it is in fact the case. So that's where a lot of the confusion lies at this point. It's not very obvious, but there are so many things in astronomy which are not obvious, like the basic fact that we don't feel ourselves moving at unfathomable speeds. Yeah, there are a few different theories. I could talk more about it if you want.
If I could understand it, that'd be great.
Yeah. Has it been understandable so far?
Yeah, you're doing pretty good.
That's good. I mean, I try not to like talk to myself. And yeah, and astronomy.
You and me both.
Yeah, yeah. Sometimes it feels that way. Astronomy. Yeah. You could quickly make something that's too hard to understand if you get into celestial mechanics. I have a good ability to understand spatial awareness type intelligence, so that really helps me out with this question. So I'll try to explain more. It's interesting to see the history of astronomy going from one question to the next without necessarily having answered the old ones. That's definitely what's happened, and now we have the ability to ask new questions that nobody had even thought of in the past, because we have the James Webb and other observational powers. But it doesn't mean that all the old questions have been answered. Even questions about how the moon moves. The moon gave Newton headaches, and Mars has been a problem for astronomers since the days of Kepler, who was at the very beginnings of astronomy. One of the interesting possibilities for our system is that the Sun and Mars are binary companions. But this maybe doesn't work because Mars is not very bright, and when we see most binary star systems, we can see two bright objects. However, it may work still, because as we have developed better observational techniques, everything really in astronomy is called into question, and they make digital textbooks now so they can rewrite them from one year to the next, and the professors have to catch up. It's rapidly evolving, and when Newton's theories were created and our ideas of how stars and planets form and what is a star and what is a planet, we only really had our system to go on. But now, although exoplanets, planets around other stars, can't be seen in any detail, and if you see a picture of one, it'll say artist's conception, just a guess. But we can see that there are many different types of star and planet systems, and ours is just one, maybe not very typical example. The question of what is a star and what is a planet and how stars and planets form is definitely not answered. And the fact that almost all stars are in binary systems definitely raises questions about, do stars form in binary systems, or do they find a partner later in life? So Mars is not very bright, but many of the stars which are inferred to be binaries are done through spectroscopic analysis showing redshift and blue shift, which indicates that the star is moving towards and away from us at a certain rate, which indicates that it's orbiting around something. And the simplest way to describe what a binary star system is compared to the old idea of what our sun is as a single star system is that a binary star system has some kind of local orbit. Let's see if I can demonstrate this. If I'm the sun in a single star system, I'm just going to go around the middle of the galaxy, typically in a circle. But if I'm the sun in a binary system, I'm going to go around the middle of the galaxy around something else, and it's going to look kind of like this. So from any point observing me, I'm going to be going towards and away from you a little bit, and that can be seen in the spectra. But many of these stars, which are seen through the spectra, could be going towards and away from us on a cyclical periodic basis. We can't actually see 2 points of light, even with adaptive optics and the most advanced telescopes. So, could Mars and the Sun be in this dance? It's a radical idea. There are some less radical ideas, the least radical being that, well, Jupiter maybe counts as a binary companion to the Sun. And then basically we get rid of all of these problems, except that we don't have an explanation for precession by calling Jupiter the binary companion of the Sun. There's a model which has been put into a software simulator with the Sun and Mars as binary companions, which does model precession as well as putting Jupiter where it should be and showing eclipses in the simulator at the exact time that we see them. It works as well as the Copernican single star simulators for modeling what we see in the sky, and it also explains precession. So that's why I think it's very interesting, as well as a few other aspects of the model which speak to me almost philosophically or spiritually. There's a lot of resonance in this system, harmony and resonance. And in the Copernican system, not so much.
Can we see Jupiter or Mars right now in the sky?
Yes.
Oh,
We should do some observing soon.
let's do it.
I hope that was interesting. I hope that was interesting. We got into the weeds on this topic.
Very cool. On the binary dance that you just demonstrated out here, do we know kind of what kind of time frame are we talking about? You know, thousands of years, tens of millions of years, in terms of their revolving around each other?
Yeah, it's a good question. Anything from many thousands of years to just a couple days has been observed in other star systems. Yeah, so very fast, close relationships, all the way up to many thousands of years. The North Star is actually a triple star system.
Is that right?
And two components are very close together, which are called Polaris A and Polaris AB. And then there's Polaris B, which is so far away that it takes thousands of years to go around the other two. And we don't know exactly how long because it's so far away from the other two, it's hard to measure exactly.
So how did you know that they were part of, all three of them were part of a system?
Sometimes you can look in the sky anywhere, even where it looks black with a telescope, and you'll see stars which are just coincidentally close to each other from our perspective. But by measuring very small changes from one year to the next, the star's proper motion can be measured, and when two stars that are close to each other have the same proper motion and red shifts and blue shifts that correlate, it's pretty likely that they're in a relationship with each other and the same distance from us. Also, parallax measurements can show that they're about the same distance from us. So that's how it's understood that they're not just coincidentally in alignment from our perspective.
And that's like you also true with the Polaris B, that maintains a certain distance from the A and AB?
Yeah, it will get closer and farther away from our perspective over many thousands of years, but it's such a large orbit that we can't see it. There are some other binary systems like Castor, which will be rising soon, that have a period of 80 years, and that's something that Starman Steve has seen get wider and then closer over his 30 plus years of observing. We will see Mars maybe rise pretty soon. This is Jupiter. Let's take a look in the telescopes, and we've got Orion rising in the east. We've also got Saturn up here.
That's always nice.
It's the moon.
And we'll take a look at the moon in the telescope. That's always a highlight. Have a look in the digital eyepiece of this one. The fireworks galaxy here, NGC 6946, is looking good. And what is a galaxy?
Another solar system.
Not quite. This is the distinction that we want to make here between what is a solar system and what is a galaxy. It was only 101 years ago that Edwin Hubble discovered that fuzzy things, which are often in a spiral shape, but not always, which we now call galaxies, are really far away. They're not in our own galaxy, which is called the Milky Way. And galaxies are sort of like their own universe. We're going to see a spiral galaxy here containing about 50 billion stars, which are really far away, and all we can see is the mishmash of 50 billion stars combined light into the spiral shape that they are found in. We'll also see stars which are closer to us, which are in the Milky Way. And everything we can see with our naked eye is in the Milky Way. It's a little bit confusing because we're in the Milky Way, looking out and through it, and all of the galaxies outside of it are too far away to see with the naked eye, except for one, which is the closest galaxy to us. Anybody know what that one is? It is Andromeda.
Oh, ding.
And we could see Andromeda if the moon was not out, but with the moonlight, it's too hard to see, but it is right. Oh, where am I? What time is it? Here it is, right overhead, basically. But it's washed out by the moonlight, so we can't see it tonight. However, Andromeda is not that interesting in a telescope, so I chose a different one which has a spiral pattern, because Andromeda is an elliptical galaxy, and it looks just more like a blob in a telescope. This one is cool. It has a spiral shape. Our own galaxy, the Milky Way, also has a spiral shape and contains about 200 billion stars, including all the ones we see with our naked eye, and many, many more. So a solar system is what happens around just one star, or around a binary star system, as the case usually is. Solar system is one star or two stars in a binary system, and whatever planets and moons go around that. So when we see Jupiter, it looks like a very bright star. When we see Saturn, it looks pretty much like a bright star. With the naked eye, you can't hardly tell the difference between Fomalhaut and Saturn. But Saturn moves relative to the background stars, and that's what planet means. It means wanderer. However, in the telescope, it looks very different. If we were to look at Fomalhaut in the telescope, it looks basically like what it looks like to the naked eye. With Saturn, we will be able to see the rings. So let's take a look. Let's take a look. Have a look here, and take a look here. First with Jupiter.
Gotta get out of my chair.
Teddy, bring it here.
That'd be too easy. That would be the non-active travel.
Yeah, exactly.
That's the Dorothy.
The nearest star, Earth would be